Okay, welcome to our CCNA course. This is CCNA 200 301, which is the latest course, and this is the first module where we are going to be talking about uh, introduction to networking, and this is the first slide. So I want to welcome you to this amazing teaching. So right now we're going to proceed. So the first module, you see, we talk about networking today. You understand? First of all, when you want to hear the word networking, what comes into your mind? Networking is interconnectivity, or is interconnecting node, city, object with the help of network or transmission mediums like cable, roads, for the purpose of sharing information, data, communication, and ease transactions. So now that is networking. So now, what is computer networking? Computer networking is the interconnectivity of or interconnection of nodes or endpoint devices to ease communication and to share important resources or services. Okay, so in this course, we are going to talk about, in this module, we are going to talk about network affect our life, how network affect our life, network component, network representations and topologies, common types of networks, internet connections, reliable networks, network trends, network security, and the IT professional. So this is a table content. This one help you to guide you to know what you are going to obtain throughout this module. So let us proceed. So we have network affecting our lives. How networks affect our life today. This shows how important network is to us today. So you see, network connects us. You understand? Communication is almost as important to us as food, as water, as air, as shelter in today's world. Through the use of internet or networks, we can connect like before. It is very, very important, because just imagine in the time where they were using post office to send information. You see, if you want to send an information to your brother, maybe out of a city, maybe you are now in, let me say you are in Yaoundé, and then your brother is in Bamenda, and then you want to communicate something very important to your brother. What you do, you need to write a letter and take it straight to the post office. And the post office now we collect letters from different persons and then transport that letter to the destination, which is Bamenda. That's how people were being that's how people were being connected, like sharing, communicate. That's how people were communicating in those days. It was good then, but there was a lot of disadvantages. For example, if you have an urgent situation at hand that you need a quick response from the receiver, the project will fail, because now the post office will not just take only your own letter and send to your destination because how urgent, or because of how urgent your information is. No, you need to gather another information or letters from different people that is going to that particular destination. So when they gather a reasonable letter, then they cannot send it to the destination. Reason being that they don't want to waste resources. Because if they are just waiting any letter they send, that one they waste resources, because the vehicle that is taking the letter from from the source to the destination need fuel. and they cannot just take only your information and take it to your destination just you alone, because your information is very, very important. So you see, at that time, communication was very slow because of the procedure and the structure that was in place. But now, due to the help of internet or networking, in the word of networking that have led to an internet, now you can easily communicate. You can easily communicate to your brother in United States as if the person is with you in the same location or the same house. So that's how internet has really network has really affect us. It has connected it has connected us together irrespective of the distance. So this is a video that fortunately the video is not here for us to play. So now you see, with the help of networking, we feel there's no barrier. But if you want to see your brother or your relative out there, you just need to go through WhatsApp and you do a video call and you see the person as if the person is close to you. You don't feel the absence to the person that much, as long as you can hear the person at any time through networking or through internet communication. It is very, very easy. So that is how network have affected our life today. It has connected us in such a way that we feel no barrier among us. The way is without barriers, and the global communication and human networking. From there, you can have friends from India, friends from China. I remember when we're carrying a study on cybersecurity in one big international school of technology. In our batch, there was a lot of people from different continents, from Africa, from Asia, from US, and different countries: India, China, Nigeria, Cameroon, USA, Canada. And with that, now we are able to interconnect, like have a relationship with human networking. With that, it gives us the privilege to have friends abroad where you guys can share information, share ideas based on the course, based on the study that we're carrying or the study that we're doing. You see, all this is due to networking. So networking is very, very important. Can you emphasize that network is very, very important in our life today? Networking today. So when you hear about networking, we say networking is an interconnection of nodes or endpoints. Computer networking is an interconnection of nodes or endpoints with the purpose of communication, sharing of resources and services. So when you hear all these things, it implies that there are components, things that builds a network. So we are going to see some of these components that builds a network. So now we have some of the components. We have hosts. The first component of a network is host. When you hear host is any computer on a network. Any computer on a network is called a host or an end device. When you hear an end device or a host, know that it's a computer. And a computer can be a laptop, a desktop, or even a server. A server is a computer which have a great capacity or great property to render a particular service in the network. So a server is a computer that provides information to the end devices. Yes, it provides services to the end devices, like email services or email server, web services like web server, file services like file server. While clients are computers that request to the server to retrieve information. Client are people that like they enjoy the services from the server. They call them client. But all their nodes or hosts or end devices. So for example, you can see this is a server here. This server might running a service of a mail service, a web service, or a file service. And this is an internet, which is the interconnection of networks. So now you might be here as a client. Now you are requesting for services here in this server. For example, I want to use a clear example. This is you here with your computer, and this is the email server, Google server, where the email is. So when you are accessing your email from this your PC, you are requesting as a client to this server that, hey, I want to access my email account of this server. But your email account is being hosted here in this server. But due to the help of networking, you can start from your home here as a client to access your email account through email account that is being hosted in the email or the Google server, which is being hosted in America, not in your country. So we said a server is a computer that provides information to the end devices or a host or a node. And a client is a computer that requests to the server to retrieve information, to request, to use, or to benefit, or to carry out some particular services or enjoy some services provided by the server. So we have the different types of server. We have email server, we have web server, we have file server. So now we have another component. This is a peer-to-peer. When you hear about peer-to-peer, what comes to your mind? A peer-to-peer is just like a point-to-point connection. It is possible to have a device, be a client and a server in a peer-to-peer network. First of all, I want to talk about peer-to-peer network. What is a peer-to-peer network? A peer-to-peer network means a point-to-point network. That implies that a server is connected to a client. This is a point-to-point network. Or a router is connected to another router. This is a point-to-point network. It's called peer-to-peer network. A point-to-point network. That implies that there is no other destination, like from one point to another point. That's a point-to-point network. Or it can be a PC connected to a PC. This is a point-to-point network. So this is a point-to-point network. So this type of a point-to-point network is mostly common in a small network environment, where you see this is a printer, and then you have a PC connect to that printer. This is a point-to-point, and another PC connect to another PC. This is another point-to-point. So what happened? This PC A, he is the one advertising the printer to this PCB. He say, I have a printer to share. Why this PC say, I have a file to share. So in this particular moment, when this person want to use this printer, he pass from here to this another point. So this is a point-to-point network. This can only happen in a smaller offices, which is a smaller area network, a smaller offices. You can still only find point-to-point network at the core level of a particular network, where a point-to-point between two core routers. So advantage of a peer-to-peer, it is easy to set up, less complex, as you can see, low cost, don't spend a lot, used for a simple task like transferring files and sharing printer. Disadvantage is that there's no centralized administration. You see, for this man to access this server or this printer, he must pass through another node, and there's no security, no scalability, scalable. It's not scalable. Slow performance. You see, so that is a peer-to-peer network component. Okay, now we have another network component, end devices. So what is an end devices? We say an end devices are a computer or a server or maybe an IP phone. That's an end device. Like you see here, these are all this one is an end device, 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 this one is an end device. This is an end device, this is an end device, this is an end, this no, this one is an end, this is an end device, this is an end device. So an end device is where a message originates from or where it is received. That is an end device, where a message is originated from and where it is received. For example, this is you here. This is you here, you, and this is me here on my own laptop here. This is my local area network. This is your own local area network. We are interconnected through a service provider. So now you send me a message maybe on, maybe on WhatsApp. Hello, on your PC. Hello. What are you doing? You are generating a message. So where you are generating a message, you are generating a message on an endpoint device. So now, me here, I'm going to receive that message here, the hello here. Why? This is an end device. Likewise, I can generate a message here and you receive it. So an end device is where messages are originated and where it is received. That's an end device. That's an end device. So we'll move further. Intermediary network device. That's excellent. Intermediary network device is like the device that help to interconnect the endpoint device. An intermediate device interconnect the endpoints. Example include switches, wireless access point, routers, and firewall. The management of data as it flows through the network is also the role of an intermediary device, including regenerating and retransmitting data signal. Wow, I would like to break this down. So, first of all, it says an intermediate device helps to interconnect endpoints. For example, you have a node. Let me say you have 5 endpoint devices in your office PC. You have a 5 endpoint in your office PC, and you want this. Let me say 4. You want this 4 network to interconnect through the internet. We are one router here. What you need now, you need another intermediary device, which is a switch, which will help you to interconnect these different endpoint devices to one area network, to a local area network. Then this switch now will help to connect you to the router, which is connected to the ISP, so that this node can receive internet, or they can share files within their local area network. So what is the function of the intermediary device? You say, one, to interconnect the end node. Number two, to manage the data flow. How the data move from one node to another. How it is, which level, the level that it passes. You see? And number two, it regenerates and retransmit data signals. For example, when you are using Ethernet cable, like a twisted pair cable, it has a maximum length in which it cannot exceed unless there will be that signal loss, like 100 meters. 100 meters. So for you to regenerate, if you have a distance of 200 meters to cover with an Ethernet cable, for you to regenerate the signal at this end, at the point of 100 meters, you need an intermediary device. So when you put from your endpoint and straight, and this position is up to 100 meters, you need an intermediary device, maybe a router or switch, to break this and regenerate the signal again, so that there should not be a loss. When you want to reach again 100 meters, you need another intermediary device again to regenerate and retransmit the signal again. And then it maintains the information about what pathway exists in the network. Because when, for example, when you connect, for example, you have a router here and a router here, and then you have a switch here, and this switch is connected to this router, and this switch is connected to this router, and then behind this switch you have different nodes or hosts or end devices. So now, and then at this edge you have these two routers connect to an ISP, which is the internet. So it implies that these nodes, these two nodes or end devices behind this switch, has two gateway to reach the internet, which is this interface and this interface. So the intermediary device helps to maintain the information, or in which that path in which the packet or the information passes from this node to this one. So it checks where the information needs to go, maintain the traffic flow or the signal flow or the packet flow to the destination. Another thing, it notifies other device of errors and communication failure with the help of some particular protocols. When the devices are well configured with some protocols like SNMP, it helps to generate notifications based on the issue within the network. So that is a function of intermediary network devices. So we'll move further. So I've seen the different size, different types of intermediary. We have wireless router, LAN switches, router, multi-layer switch. When you see multi-layer switches, talk about layer 3 switches that operate as a router, and this operate as a layer 2 switch. We have a firewall appliance. So let's move further. So we said that computer networking is an interconnection of end devices or nodes to share information and communication. But the interconnection needs what we call network medium or medium or media. Network medium or media, it can be wired or wireless. Communication across a network is carried through a medium which allow a message to travel from a source to the destination. So it helps to allow the message to carry from the source to the destination. There are two types. You have the metal wire within cables. You have the glass or plastic fiber within cables. And we have the wireless transmission. So I always say there are two main types, the wire and the wireless. And then for the wire, you have the different categories of cables, like the fiber optic cables, the twisted Ethernet cables. So these are various types of cable. We have the copper, we have the optical fiber, and we have the wireless. These are the medium in which information or message is being transmitted from the source to the destination. So it is very, very vital to know the different types of network media or medium. Network representation and topologies. Okay. When you hear about network representations and topology, we know what comes to your eye is network diagrams. So network diagrams, often called a topology diagrams, use symbols to represent devices within the network. So these are some important terms you need to know as a network engineer. Network interface card. Physical port and interface. So this is an endpoint device up here. If you see, this is an endpoint device up here. We have desktop, laptop, printer. This is television. We have wireless tablets. We have iPhones. We have again intermediary device. We have wireless router, LAN switches, router, multi-layer switches, firewall appliances, and then we have now the network medium or media. We have the wireless media, we have the LAN media, we have the WAN media. This is a serial link, a serial cable. This is a copper cable and this is a wire. This one can also be a fiber optic, because they use fiber optic for WAN connectivity because of the quality and the standards in which it can carry signal from one source to a destination. So every network device, neither be a node or an intermediary device, have a NAC, which is network interface card, and has a physical port and has an interface, because this is where this network media will be plugged in order to connect the different nodes or devices in a network. So we will learn more as we go further with this our course. So now we are talking about network topology. I mean the topological diagram. First of all, you need to understand that there are two types of topological diagram that governs a network. You have, when I'm talking about two types of topological diagram, I'm not talking per se in terms of the different kinds of topology that we have, the bus topology, the ring topology, the mesh topology. When I'm talking about the two types of topological diagram, I'm talking about in terms of the functionality of a network. Because the bus topology, the mesh topology, those are physical topological diagrams that illustrate physical locations of intermediary devices and cable installation. Now, you talk about the physical connectivity, how the devices are being connected to each other. What are the materials used to connect the devices? That means the network media used to connect the devices. What are the devices connect? What are the devices involved? The endpoint and the intermediary devices. This talks about the physical diagram of a network. For a network to be fully functional, you need the physical aspect and the logical aspect. The physical aspect is the aspect of where the hardware are being placed or interconnected to carry out a particular task or a particular service. Then the logical aspect is when a configuration is being configured due to the services or due to the function, the functionality you want that network to operate on. And this involve the IP addressing, the IP structure, the protocols configuration, and the different port configurations. These two topology helps the network to operate perfectly. So the physical topology diagram illustrates the physical locations of the intermediate devices and cable installed. And we talk about the physical structure or architecture of the network, while the logical diagram illustrates devices, ports, and address schemes of the network. Address schemes of the network talks about the different addresses that is being placed to a particular device on the network, because the devices communicate based on their addresses. For example, if I want to talk to you, I need to know first your information. 1, your name. 2, what do you have, like your phone number. 3, your house. Your phone number indicates that if I don't want to come and see you physically, I can call you. At least for communication to happen, I must have your address. I must have something for you and I to communicate. If I want to communicate with you, I must have your address. Like, okay, this is your number. I call, pim, 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 pim. I call, hello. You answer, hello. Okay, if I don't have your number, I need to know your address, your house. I'll walk there and go and meet you for you to see you in your house so we can communicate. So there must be an address. So the address schemes is a logical topology diagram of a network. And for a network to operate perfectly, these two must work in simultaneously. For example, if you see now, this is the physical aspect. You see, we have the server, which is an endpoint device. We have the intermediary device, which is a switch 1. And the switch 1 now is connected to a router. And a router is connected to another switch 1. And this one is connected. Now, this is a server room. This one like this is a server room. While this one now is an IT office. You see, now this is now the physical topology diagram to illustrate the architecture of this company. Then you have now the room number with their different switches, and I believe they are running in different VLANs. You see, class 1, class 2, class 3. So now, if you look at this diagram, you will notice that there is no addressing. There is no addressing. It's only just the label and the placement of the devices. So now when you come now to this another section, you see that there's a placement of network addressing. You see now, it implies that this local area network like this operates in the network 192.168.10.0. You come to this another network here. So this is now the labeling of the logical structure. When they are configuring the network, they know that the address on this network is this address. So an addressing is not a physical thing that you can touch or see. You can touch it, but it's a logical command that puts the hardware devices to work to execute a particular service or task. So we continue as far as we go. We're going to learn more. Just stay tuned and let's enjoy ourselves. So common types of networks. We have a network of small size. Yes, this is if you see from the picture, a small home network. This is solo. Just like, how can I say, a cyber cafe. A small home network connect a few computers to each other and the internet. A small office or home office enable computer within a home or remote office to connect to the corporate network. So networking, it doesn't mean that it must be a broad. Even if you connect two phones using Bluetooth, that's already that's networking. You are interconnecting two end devices using a wireless network medium. And at that particular moment, they can share device, they can share resources, share files. That's already network. That's a small home network. A medium of large network, many like many location with hundreds or thousands of interconnected computers. A wide area network, I always say a wide area network is the interconnecting two or three local area networks. So as we go further, we're going to break this down in the most simplest way that you can digest it like never before. So we have the local area networks and the one area network. A local area network, you see, a local area network, if you look from this diagram here, you see the different color. We tell you, as I just explained previously, that a one area network, this is a one area network. I say a one area network is an interconnection of two or three local area network. This is a network of a company, and this is a home office of maybe the CEO of the company. This is a central headquarter and this is a branch. This is a central headquarter and this is a branch. So now, since this is a CEO that needs to get in touch with some documents, irrespective of his location, he must not be in his office or must not be in his office, but he needs to be getting information. So he had to interconnect his branch, the central office, and with his home office. This can be done with the help of an ISP. This cloud show an ISP, which means internet service provider. So the local area network and the one area network are the two most common types of networks that you will see even in the production unit. Even when you go to the field, you will see majority of the network types of network you see is a local area network and a one area network. So a local area network and a one area network. A local area network is a network infrastructure that spans a small geographical area. A one area network is a one that spans a wide geographical area network. You can see. So the difference is between the interconnect endpoint in a limit area. It's administrated by a single organization or an individual. It provides a high-speed bandwidth to internal devices. Yeah, because definitely they are directly connected to their servers and their nodes. There's no interference because the distance is very close, and it is managed by a single person or a single organization or a single person or individual. But a wide area network, it is different since it occupies a geographical area. That implies that typically I'm saying or one or two service providers, because and typically the speed link will not be fast and speed compared to a LAN area network. So the internet, when you hear about the internet, what comes to your mind? I said the internet is very easy. The internet, it is the interconnection of networks. So for example, you have Mr. Mark Zuckerberg, the Meta CEO. He has his network here. This is a Facebook server connected to his PC and centralized switches, and his office, his team and data center, they are connected here. And then now they pay to an ISP in United States. It's an ISP in United States. And then now you are your home with your phone. Your phone is connected to a BTS, which is provide a BTS of any telecommunication network, being Camtel or whatever. The BTS now is connected to an ISP. So this is an ISP. This ISP has their own interconnection. The Camtel, for example, Camtel is an ISP. It has its own interconnection, connecting to another network, connecting to another network, connecting to another network. So if you are browsing from here to Facebook, you move from here through and you flow from there. You can now get to this network. So an internet is an interconnection of networks. Different networks. You can see from here. This is LAN A, this is school, this is business LAN, this is government LAN, this is hospital, and all of them are interconnected through an ISP, a safe internet service provider. So that is network, and this network is not owned by an individual or a group, but a particular group helps to maintain the structure of the internet. And you can see the groups, the IETF, the ICANN, and the IAB. Why? Because there must be a maintained structure in such a way that things there is a particular law for a person to manage a public IP address, because there's a difference between a private IP address and a public IP address. A public IP address can only be given to you by an ISP, and this organization, they are there to maintain that there is a structure in such a way that they can manage these things, because since it requires a source of income and money, there must be a body or a group to manage it, to make it be very, very affordable. And okay, let's continue. So before we continue, there are different kind of network media used to connect different networks in the internet or internet. You have copper wire, we have fiber optics cable, and we have a wireless transmission like the satellite. So it's good to know that. So we have an intranet and extranet. So you see from this circle, this is the internet, which is a word. You have the extranet, which are suppliers, customers, and collaborators. I have the intranet, which are company only. So when you read from here, say an intranet is a private collection of networks and one internal to an organization that it means to be associable only to the organization member or other authorities. While an extranet, while an extranet may use an organization may use an extranet to provide secure access to their network for individuals who work for different organizations that need access to their data on the internet. Okay, for example, now when you become a service provider, you operate at this particular level as an extranet because personal companies like the banks that need services like MPLS, that need services like dedicated list line, that need services like other kind of services, they use part of the access part of your data or parts of your devices in the network before communicating. Like for example, now, if you have a UBA bank here in Yaoundé, I have a UBA bank, let me say in Nigeria, let me say Lagos City. This local area network here is within that company, which is an intranet. That is only the company can have access to their data, or an authorized person, like maybe an antique, which is a big cyber security company, a state cyber security company in Cameroon that have charge to secure the data that get in and out the country. That is, he has an authority to have access to your data to see if they are secure and you are following some particular company or country policy. So now, when you move for you to communicate with your branch outside there, you go through an extranet, which is a service provider that give you some information for you to pass through to communicate with your branch through the internet. Let's move further. Internet connection. Internet connection. So internet connection, there are many ways to connect users and organizations to the internet. Popular services from home users and small office include broadband cables, broadband digital subscriber line, wireless WAN, and mobile services. Number two method, organization need fast connection to support IP phones, video conferences, and data center storage. Number three, business classes interconnection are usually provided by service provider and may include business DSL, dedicated list line, and metro internet. So this is talking about the different technology that you can interconnect different networks in the internet. What are the things that you can use? In a smaller office, you can just use in a smaller office include broadband cables, broadband dedicated subscriber line, like what we have, phones, wireless. This is like um, um, satellite. Satellite serves as a one area technology to interconnect different networks to another networks. We have dedicated list line, which is being paired by an optical fiber line from the ISP to the CE router. So these are the different types of technology used to connect different networks, the internet. So home and small office internet connection. You see, this is a home user can use DSL, cable, circular, satellite, and dial-up phones. These are different uh, description and advantages of the characteristics of different technology used to connect the different user to the internet. Because in a small home you can use cables and DSL. In a teleworker, that means somebody that you are always mobile, you might use cellular. You own your this thing on your phone, you are good to go. If you are a small office where it's a fixed small office that require more notes and you have more services that you are rendering to the society, you need an advanced level of technology to connect to the internet, like the satellite and dial-up telephones. So you see the different characteristics here. Cables, high bandwidth, always on, internet offers by cable TVs service providers. The DSL, high bandwidth, always on, and then internet connections that runs over a telephone line. Cellular, use a cell phone network to connect to the internet. Satellite, major benefit to rural areas without internet service providers. Dial-up telephones and inexpensive low bandwidth option using a modem. So these are different technologies that you can use to connect in a one area network or in the internet. So these are one area technologies to connect in the internet. Thank you. So business internet connection. This one now is when we are talking of the big boys, because that one was small home teleworker. It was just like, if you want me to pay, I was just like one to one or one to many or one to this. But this one is many to many. Like this is a business network interconnection. This require a high capacity of technology where it can carry out a lot of services within the network. That's why he says you need to have high bandwidth, dedicated connection, manage services. You see, delegated list line, intro internet. Metro internet, business DLC, and satellite. So dedicated list line, these are reserved circuit within a service provider network that connect distance office with private voice and or data network. So Ethernet 1, this extend LAN access technology into the network. DSL, a business DSL is available in various formats, including symmetric digital subscriber links. So these are the different kind of technology to use to connect businesses. Like for example, you cannot take a business to use like this an organization, and this is an internet provider. Maybe organization can be a bank, and then you ask the bank to use cellular technology to connect to the internet. How can the cellular technology find like provide a suitable network, to all the network components in this building? Even if you use a phone as a hotspot to hotspot all the devices through wireless communication, it will not still provide a suitable connectivity. So you see, when you look at the smaller networks and with the bigger network, you see the technology, the one technology changes. So this is just an introduction of networking. As we go further, we'll be taking some of these technologies and bring them down and even configure some to see how it works. So that is why I see I'm just rushing and going further. We know that in the long run, there's session for that. The convergent network. So before converging a network, an organization would have been separately cables from phones, video, data. Each of these network would use different technology to carry out the signals. See, convergent network implies it's a technology where a particular medium can carry voice and reach in a particular way. They can convert the signal into a different signal. For example, if a service provider from his PE router, that is provider edge router, going straight to the CE router, which is a customer edge router, using an optical fiber. From here, they'll use an Ethernet cable, and then the Ethernet cable will have a converter. Since you cannot use an Ethernet cable to run from the customer edge router to the provider edge router due to the distance limit, because as Ethernet you cannot exceed 100 meters unless you have to bridge the network with an intermediary device to regenerate signal and retransmit signal to avoid signal loss. So but with fiber optic, you can go as any distance you want. So in the transmission level, they will use a fiber optic to transmit the signal from the provider edge router to the customer edge router. But from the router, you will be living you will live in the router through an internet cable, and then there will be a decoder or a modem, a decoder, a converted decoder that will convert this signal now from passing from through an internet now and give it through a light rays as optical fiber to pass from that distance through the transmission level, and when it reach at the customer end, he will get into a same decoder again to be converted now to pass through the internet and get now to the customer edge router. So this conversion is like converting a signal, being voice or IP, to a particular signal with the help of a converter module. So you see, you have a device here. You have an end device here. And then this end device is passing through a medium, a network, a computer network to provide a particular message. Then this is a telephone device. This now pass through internet. This one is just giving the data and information like that. But this one is voice. And this one now is video through a broadcast network, a video. So we'll go further. You see, you understand more as we're going to explain. Are you still there? Are you there?
Yes, I'm here.
So now this is the converging network. So the converging network carries multiple signal or multiple services on one link, including voice, data, and video. The converted network can deliver data, video, voice over the same network infrastructure. The network infrastructures use the same set of rules and data. So, like for example, if you see the way telecommunications company works, like for example, right, I want to use FTTH. You have FTTH. You know, your FTTH service carries voice, right? It carries data, and it carries video. Even though they are still working on their IPTV, it carries video. That is the functionality of the FTTH. That means fiber to the home. When you pay for the package, the signal, the module converter can compress all these different signals than to use different line to send voice, different line to send video, different line to send data. With the help of the module converter, you can now compress all this into a single line. And then at that particular point, when going, there's a possibility that you can still split the information irrespective to the end note. Irrespective to the end note, you can still split it irrespective to the end note. Like for example, when you have your modem at home, after paying FTT hash, when you leave the ONT, you move to the splitter. To the splitter, you get to the FAT. To the FAT, you go to the OTN. In that OTN, which is at your house, there are different ports there where you can plug. When you plug, there are different network interface or ports there where if you plug, each port can carry different service. Each port can take data. This one can take voice, and this one can take video. But it left the service provider as a single communication or network media, carry different network signals like data, voice, and this. That is how the converging network works. Let's continue. So at this point, you need to download a packet tracer, where we're going to make another lesson concerning how to download the packet tracer. But I believe you already have packet tracer. So now get start in packet tracer. Know you are familiar with packet tracer. And then network presentation. This one is a practical course of packet tracer. So we have reliable networks. Reliable networks. Okay, this is a very interesting slide. You know, as a network engineer, the one thing that you need to know when designing a network, you need to put in mind that you need to have first a reliable network. A reliable network, that implies that a network that can be easily accessible, a network that is available at any time, a network that is confidential, it has integrity, and is available. And for you to bring these three major factors in a network, you need to ensure that there's no fraud, there's a fraud tolerance, there's a quality of service, there's security, and there's scalability. With this, we will give you a reliable network. So you must put these 4 characteristics in your head to ensure that your network to be reliable. So as we go further, we'll be taking each point or each of these characteristics and elaborate and see how it serves as a characteristics for a reliable network. So fault tolerance. A fault-tolerant network limits the impact of a failure by limiting the number of affected devices. Multiple paths are required for fault tolerance. This calls for redundancy. As a network administrator, you must be a network to have a redundancy. That means there must be a high availability. There must be a high availability. You can see very clearly in this diagram here. I remember I sketched such a diagram in our previous slot. This is the internet. This is a LAN 1. This is a LAN 2. This last one, LAN 1, has a router of this. This is a gateway, and this is a gateway. This gateway of LAN 1 can pass through this router, can pass through this another router to get to the internet. Same, this the LAN 2 gateway can pass through this and can pass through this. Why? Is to maintain high availability, in the sense that there must be a redundancy. When you put a network in this kind of architecture or this kind of design, it helps you to fight against fault, or to keep your network in check, irrespective of what happened. For example, if this router goes down, this router will pass this way, and go to the internet. If this one to go down, this another router, this one this way, will pass in this way. For the time this one will be going this way, and now you can send the team to go and troubleshoot what happened with the other router that went down. So with this, it will not affect your network per se, that your network will cease from internet, or your network will cease from performing. No, your network will still ongoing like that, like as if there was no fault in your network, because of the good architectural design, by implementing redundancy in your network. So if you want a reliable network, you must always have an architectural design that have a redundancy structure. Let's continue. Scalability. This is another aspect of a reliable network. A scalable network can expand quickly and easily to support new work users and applications without impacting the performance of the service to the existing user. So when designing a network, you need to understand in your mind that if this company grow further, where other workers or users will be needed to carry out a particular services or responsibility in the network, you need to structure your network so that there will be a way that you can put the worker, or you can add devices or add another things in the network without you affecting the original network in any way, being the performance of the network, being restructuring the network. Because if adding something or adding note in your network will cause your devices to go off, that is downtime. Downtime means your devices are short from their normal operation time. That means even they go off and come down, the time that they have been not functioning is a downtime. If your network that you have structured come to happen that if you want to add another devices or nodes in your network, you need to have a downtime in your network, that implies that your architectural design is not good enough and it cannot give a reliable network. It implies that your network is not scalable enough. So for you to have a reliable network, you must have scalability in your network in such a way that if you add a network, like for example, if you see this is an old architecture of the previous design. So now the company requested for another 3 nodes to be added. You see, it is very easy for the engineer to add another node because he used a router that have several network interface cards or ports in such a way that it can easily add another subnet or VLAN into the network. So with this network can be managed as a separate network to carry out a different services within that network, because it can be applied as a VLAN. It can be applied as a particular subnet that can operate as a general, and with this, it cannot affect these different networks. So let's continue. Quality of service. Quality of service. This is very, very important. Quality of service. A voice and a live video transmissions require high expectation of those services being delivered. Have you ever watched a live video with constant break and pause? This is caused when there is a high demand for bandwidth than available, and the QoS, which is a quality of service, is not configured. So quality of service, it is very important to configure the quality of service. So the quality of service is a primary mechanism that is used to configure in a device so that the device should be able to be providing the constant required bandwidth or constant required amount of service that a particular node is requesting. So this helps the router to easily manage a flow of data and voice of traffic within the network. So if it says this person need to use 10 bandwidth, 10 mega per second as bandwidth, there must be a quality of service to ensure that that company use or that company gets is 10 megabit per second. There is no packet lost. There's no packet lost. So with this now, it makes the network to be reliable. So these are 10 characteristics of a reliable networks. So we are going to the 4 characteristics of a reliable network. These are the things that you, being a network engineer, you need to have in the back of your mind, so that when you are opportune to carry out a project in a company, for you to illustrate or to carry a project of the company, due to your architectural diagram, we explain the level of the level of your knowledge in networking. Because one thing a client will not like is when he starts facing challenges to execute or to enjoy a particular service within his network because of maybe poor quality of service, maybe no fault tolerance, maybe no redundancy. Like there's no redundancy in the network. You see, all these things now can make you lose credit before your customers. So it is very important that you know these things. It will help you for you to install a particular network in a place, because with this now will help you to know how to organize or to design your network. Now, number 4 is network security. Network security can not be overemphasized. It is a very, very, very important aspect of the 4 characteristics of a reliable network. Because as technology grows, crimes cyber crimes keep increasing, and especially when your network is passing through the internet, where you don't know who is who in the internet, you need to ensure that your network is secure, because an attacker can break into your device or into your network and compromise your network. And with that, your network will not be available to you as it was, because maybe virus infection or worm. So with that, files are being corrupt. You want to open files, it's unable to open. So you need to put your the network security measures, implementing some network security appliances. Ensure that your routers and your switches, your intermediate devices have strong password and login credentials in any terminal, maybe in console, maybe remote, maybe auxiliary login. In any way that I can access the devices, there should be a password and a login, and there must be accountability to see who get into your device and what the person did into your device, for you to understand, to have a clear visibility concerning your network. So the goal of security is to keep what we call confidentiality, integrity, and availability. So with this, it will keep your network 247 available for the workers and for the services to be used. So for you to have a reliable network, you need to put these four characteristics in place. Number one, network security. Number two, fault, fault tolerance. Number three, quality of service. Number four, you need to put what we call, I call it redundancy, because that is what makes, or high availability. So let's continue. Network, network network trends. So when we talk about network trends, we're talking about the advancement of networks, the advancement of technology when it comes to network. The rule of a network must adjust and continually transform in order to be able to keep up with new technology, and end users devices are they are as they constantly come to the market. So network trends is like the constant advancement of technology based on the different level of technology and gadgets in the market. So we are going to see some several network trends that affect organizations and customers. Bring your own device, online collaboration, video communication, and cloud computing. Bring your own device. Bring your own device allow users to use their own device, giving them more opportunities and greater flexibility. Bring your own device allow users to have the freedom to use personal tools to access information and communication using their laptops, netbooks, tablet, smartphones, e-readers. So bring your own device means any device with any ownership, using anywhere. So trend is like, okay, we have to make the internet or devices in such a way that wherever we are or wherever we go, with our own personal devices, we can able to access some personal resources into the network, irrespective where we are. That is why devices need to be upgrading. If you see now, we have what we call IoT, which is Internet of Things. Internet of Things is coming up where gadgets will be connecting to the internet, not only laptops. Now we have fans, we have TVs, we have a lot of things that are able to connect to the internet. So as technology go on, gadgets are being produced or upgraded to carry out a particular task based on the season. So now we are going to look on the next online collaboration. Collaborate, collaborate and work with others over the internet, over the network on joint projects. Collaborate tools include Cisco WebEx. So these now are the level of technology where now you can easily communicate or have meetings like what you and I are doing now through other platforms like Zooms. From there, we can share posts, share images, send instant informations or messages, send links. Those are trends. Video communication, like video call regarding important one I want to look at. Okay, we are going to talk about cloud computing. At first, people were struggling on how to store their data, but due to network trends, now we can have a centralized database or data center where smaller companies or individuals can store their data for future uses and for security. So cloud computing allows us to store personal files or backup our data on servers over the internet. Applications can also be accessed using the cloud. Allow businesses to deliver to any device anywhere in the world. Cloud computing is made possible by data centers. Small businesses small businesses that cannot afford their own data centers lease servers and storage services from large data center organized in the cloud. So cloud is just a physical data center. Like for example, Camte has a data center, and that data center is a cloud service because people that are not in this country, they host and store their informations to that cloud because of security and for further usage. So that is that. We move to, so you have different type of clouds. You have public clouds available to the general public through a pay per use model or a free. You have a private one intended for a specific organization or entity such as the government. You have the hybrid, make up of two or more cloud types. For example, part custom and part government. Each part remains a distinct a distinctive object. Both both of the connected both are connected using the same architecture. So this is the different type of cloud, and It is very good for you to understand this because, as I said, a network engineer can work everywhere because the word cloud is not as cloud as we see in the air. Cloud is just a remote network or a data center, and those data centers are interconnection of switches, routers, and servers, and all this can be done by a network architecture, network engineer. So when you're hearing private cloud, it's not mean like the devices are different. Those are just clouds that are being preserved for a particular organization or government. These ones are not free publicly. So you chip in something for you to get, and their security is a top-notch one because not everybody get access to that particular server. I mean that particular cloud or server in the database. I mean the data center, sorry. So you see, this is a technology trend in the house. So as I spoke of this about the IoT where technology has grown trend that allow technology to be integrated into everyday appliance, which allow them to interconnect with other devices. So, and this calls for constant upgrade in gadgets and appliances because technology is moving in a level where every gadget or equipment need to be able to generate data that can be used to analyze and to solve a particular task in the society. So these are technology trends in network, and this keep engineers to be updated because they need to know how it functions to order to execute the various work on the field. So these are different types of network trends. So we have network security. Are you see there?
Yes, boss.
Okay. Our class is 2 hours. So we have about 20 something minutes because we started at 10 exactly. So we have network security. Network security. Yeah, we're going to talk about, as I said, network security is an aspect of networking that you cannot joke about, especially in this our modern society where network are advanced in such a way that the technology level is high and the crime level in the cyberspace is high. So the first thing that organization needs, they need not just somebody to interconnect their devices as a network engineer, but they need somebody that to interconnect a secure network system where their data will be safe and their resources will be safe. So we're going to look some network threats. So network security is an integrated part of network regardless of the size of the network. Every network needs a security regardless of the size of the network. The network security that is implemented must take into account the environment while securing the data, but still allowing for quality of service that is expected of the network. Securing a network involve many protocols, technologies, device, tools, and techniques in order to secure data and mitigate threats. Threat vectors may be internal or external. This is internal is the most dangerous one. And this is one thing that it is very, very good as an engineer. When you finish do your work, you need to inform the the administrator of that company that they need to have an awareness class to all their workers because their workers can be an internal threat without knowing. Internal threat in the sense that they can open a vulnerable website using company PC in a company network, where they can click a phishing link, where it can create a backdoor to that PC. And if it happens like that, the attackers can easily compromise the network by passing through the backdoor to breach the network. And it is very, very necessary that there should be an awareness training to be the awareness, the security awareness to the employee. They should know the various steps and policy in order to govern them, to know how they operate, especially when they are on the internet from the company site. So internal threat is when a worker being compromised by using maybe social engineering attack, or he went and access a vulnerable website, or he click a phishing link. It can be, or using an unknown external drive to plug in the computer system, in a network, in a company computer system that can insert a virus or a worm into your computer system. So it is very, very useful. And then external threat is when it is out of the network. For example, a thief, or maybe an attacker trying to use maybe brute force attacks, trying to use my SQL injection, trying to use man in the middle, trying to use different attacks to compromise the network. So with this, you can easily now know what to implement to solve the security level. External attack, you can implement what we call firewalls. To implement, to ensure that to filter and monitor the traffic that leaves the network of the company, and the one that gets into the network of the company. And then you go furthermore again, for the internal threat, you have to carry out what we call awareness training first, to create awareness to the employee how to manage a secure environment and create a secure environment. Number two, you have to have endpoint devices, maybe like firewall, endpoint application like firewall, or enable some software firewall application. And they have an antivirus application to help you to scan document before, and make sure that your sensible devices are physically locked in a particular server room where access is being restricted, to ensure that unauthorized person cannot get into the server room just like that. And it is very, very, very important. Then the kind of protocols you configure matters. There are protocols that they do not encrypt their data through transition. Data on transit is not encrypted. If the data is interfered, if an attacker interfere the data, he can see the data in plain text. So you must know those kind of protocols, and you avoid those protocols to configure or to use in your network. So we have internal threats like worms, viruses, Trojan horse, spyware. We have zero-day attack, threat actors attacks, denial of service attacks, data interception attacks and theft, identity theft, get internal attack, loss and steal devices, accidental misuse by employer, malicious employee. Those are they just get into work. They don't even know, they are not aware, they don't have any security policy awareness. They are just clicking, going to any kind of site and feel like it's if they are in one secure environment. The internet is not secured. When you build your own local area network, you can say this is secure because it's only you and a particular people that you know that are using the network. But when you are going through the internet, You don't know who is there on the internet. So you cannot just be free on the internet like that. There must be security measures to take in place or put in place. So you have security solutions. These are the kind of solutions you need to implement. Security must be implemented in multiple layers using more than one security solutions. Network security component for home or small office network. Antivirus, anti-spyware software should be installed. This is what I've already shared. To be installed on the endpoint devices